Hello and welcome again. Today we're going to talk about Geometry Section 7.1-7.2, problem solving with proportions. So in 7.1's lecture we opened up with some basic proportions, and now we're going to move on to problem solving with them with a focus more on the logical end of problems, or of proportions, excuse me. Some definitions to start off with. The first definition that we have is if we have A over B equal to C over D, then we also know that A over C is equal to B over D. So we have inverted both the B and the C from the first statement and solve there. So we hold this statement as true. We're going to prove one of these statements today in lecture, and then one of these statements as an assignment problem. Okay, so the first one, if A over B is equal to C over D, if that proportion is true, then also to be true is A over C equal to B over D. Down on the bottom, we have if A over B is equal to C over D, the same starting proportion, then we know that A plus B over B is equal to C plus D over D. So we've basically added the denominator on both the left and right side of the proportion and called them equivalent. So let's hold those statements true. I would write those down because we're going to reference them throughout the rest of lecture. Alright, complete the sentence. If 2 over x is equal to 7 over y, then 2 over 7 is equal to... So applying one of the rules we just learned on the previous slide, what would be the statement here? We know that we can invert both the x and the 7, so therefore we know that x over y is going to be what it equals. Right? The first statement we had, we can invert both the x and the y. We're using the a over b is equal to c over d. Then we know that a over c is equal to b over d. So we just flip those around. Okay, and that's using the first statement that we talked about on the last slide. Another. If x over 5 is equal to y over 12, then x plus 5 over 5 is equal to, this will probably use the second statement that we talked about, y plus 12 over 12. Alright, using again the second statement that we referenced on the first slide. If a over b is equal to c over d, then we know that a plus b over b is equal to C plus D. Get rid of that C plus D over D. So we have our A, B, C, and D as x over 5, y, and 12, and then it applies there for that statement. Alright, let's try another one. If 13 over 7 is equal to x over y, then 20 over 7 is equal to... Notice the change. What has happened from the 13 to the 20? It's been added 7, so we're going to use the second proportion statement that we talked about. So therefore then we know that x plus y over y is what it equals to. Again, the big thing to note is what happens between the first statement and the second statement, the if and then the then. Is it inverting the denominator numerator, or is it an addition of the denominator on both left and right? Okay, good. Next type of problem. Tell whether the statement is true or false. So using those proportions from the first slide, we can apply in these situations to see whether or not we have a true or false statement. If p over 6 is equal to r over 10, then p over r is equal to 6 over 10, or 3 over 5. So if p over 6 is equal to r over 10, then p over r is equal to 3 over 5. Well, applying the first statement, we know that p over 6 is equal to r over 10 implies that p over r is equal to 6 over 10. And simplifying 6 over 10 right here can be simplified down to 3/5. So therefore then, by that logic, we know that it is a true statement. Let's do another one. If a over 3 is equal to c over 4, then a plus 3 over 3 is equal to c plus 3 over 4. Can we get from the left side to the right side? If we can, it's true. If we can't, then it's false. Well, let's work it out here. If I have a over 3 and that's equal to c over 4, I know that a plus 3 over 3 is equal to c plus 4 over 4. However, c plus 3 over 4 is not equal to c plus 4 over 4, so therefore this statement is false. Okay, so telling true or false, you can make it work from the left to go to the right, it's a true statement, otherwise it's false. Two more examples. Tell true or false. If s over 10 is equal to 15 over t, then s over t is equal to 3 over 2. Well, if we work this out, s over 10 is equal to 15 over t. That implies that s over 15 is equal to 10 over t, and that's not equal to s over t equal to 3/2, so therefore false statement. We cannot invert that way. Alright, bottom statement. If 3 over x is equal to 5 over y, then 3 plus x over x is equal to 5 plus y over y. Well, let's see what we can get. From the left side, we can say that 3 over x is equal to 5 plus y, and if we add the denominator on both the left and the right, then we know that we do have a true statement. Okay, it is possible. Very good, true statement. Alright, next type of problem. Given this proportion, side AB over BD is equal to AC over CE. Find BD. All we need to do here is fill in the information from the picture on the right to the proportion on the left and solve using algebraic a solution. So if AB is 16, I can make my proportion as 16 over BD. I don't know what BD is. Try and find it. That's equal to X. That's equal to AC over CE. I don't necessarily know what what AC is right away, but I do know that if AE is 30 and CE is 10, then by subtraction this has to be 20. So then AC on my proportion will be 20 and CE will be 10. So I have my proportion of 16 over X is equal to 20 over 10. I will cross multiply and solve for my variable. There's my proportion. And I can cross multiply. 160 is equal to 20x, and x is equal to 8. So final answer, BD is equal to 8. Alright, next problem. Similar setup as the previous one. Finding segment lengths. Given that MQ over MN is equal to LQ over LP, find LQ. So MQ is the combination of MN and NQ added together, so therefore we know that MQ is going to be 21. The single part MN is 6. On the right I have LQ, which is a combination of LP and PQ. I don't know what PQ is, so I'm going to put that as X. So I have LQ as 5 plus X, as it's the entire length, and LP is just 5. So putting those together, my proportion is 21 over 6 is equal to x plus 5 over 5. Cross multiply and solving then, I have 21 over 6 is equal to x over 5, implies that 6x plus 30 is equal to 105. I have an error down here, this should be x plus 5. Continuing though, 6x plus 30 is equal to 105, implies that 6x is equal to 75, and dividing 6 on both sides, I have 12.5 as the value for x. Okay. Next example, AB over BC is equal to DE over EF. Find BC. So if I look at my figure out here on the right, I have no markings for either AB or BC. I'm trying to find ultimately BC, so I'm going to make that value my variable x. If BC is x, and I need to find AB, or have an expression written in terms of the whole statement with AB, I would know that if AC is 20 and BC is x, then AB has to be 20 minus whatever x is. Okay. Once I have that statement, then I can just plug in my values here. I have 20 minus x for AB, x for BC, DE is 8, and EF is 10. So my proportion looks like this. 20 minus x over x is equal to 8 over 10. Simplifying then, 10 times 20 minus x is equal to 8x implies then that 200 minus 10x is equal to 8x. Simplifying, we have 200 is equal to 18x, and that implies then that x is equal to 100 over 9. So again, the key was defining what AB and BC are. Alright, the last thing that we're going to talk about is our proof. We're going to prove the second statement from the first slide, which is if AB is equal to C over D, or sorry, A over B is equal to C over D, then A plus B over B is equal to C plus D over D. And we don't need to do a two-column proof like we've done with our geometric shapes and things like that. We're just going to kind of do like a flow type of reasoning algebraic proof. And it starts with the following. The given was A over B is equal to C over D. Without losing anything on both the left and right side of the equation, or the proportion, I can add 1 to both left and right, right? That is the additive property of equality. So I can put 1 on both sides, that's no problem. The nice thing about 1 is I can make that a fraction pretty easy. I can make anything over itself, for instance 3 over 3 equals 1. So the same thing can happen with variables. So therefore, I can take this statement right here, A over B plus 1 equals C over D plus 1, and turn that into A over B plus B over B is equal to C over D plus D over D, because anything divided by itself equals 1. Well, this is really good then, because now I have common denominators for both of the fractions, which means I can add the two fractions and end up with A plus B over B is equal to C plus D over D. So the key is having the additive property of equality on 1 on both sides, and then from there rewriting what 1 is, and then combining the fractions. In your tasks for tomorrow, you will have to prove the first statement from the first slide, but it will be a similar fashion as this. Alright, that ends lecture for today. We will work on worksheet 7172 tomorrow in class. Thanks for watching.